Hey everyone, thanks for joining us for today's event, Visual Test Automation with PayPal's Nemo and Applitools Eyes. My name is Adi and I'm the event's moderator. I just want to make sure the sound is working, so if you can hear me okay, please use the raise your hand option on the control panel. So show of hands if you can hear me. Okay, it seems like you can. A lot of hands are up. Okay, so that's awesome. Today's event features two expert speakers. We have Matt Edelman, which is a software engineer at PayPal, and Daniel Puderman is R&D director of Applitools. Just before I hand over the mic to Matt, some administrative stuff. Feel free to ask any question during the webinar. You can do that in the GoToWebinar control panel on your right. We will answer as many as possible at the Q&A session at the end, but even if we don't get to your question, after the webinar, we will email you an answer. So, worthwhile asking anything. Also, for optimal viewing experience, we recommend you close off any unnecessary apps running in the background. The webinar is recorded and will be made available for on-demand viewing. A link to it will be emailed to you once the recording is online. Also, if you encounter any technical issues, please send me a message in the chat room, also in the control panel, or email me and I will try to take care of it as soon as possible. So let's kick off. Matt, the stage is yours.
Thanks, Addie. Hopefully everybody can hear me okay and can see the presentation that I'm sharing on my screen. If that's not the case, let me know. So PayPal has been using Node.js for about 4 years now, and it's primarily responsible for all of the web traffic that flows through PayPal.com at this point. So all the product teams that used to be using Java to build the front end servers are now using Node.js to build those servers instead. And when we made that switch, we were still doing automation testing using a Java framework, which was inefficient for a variety of reasons, but one of the primary ones was that we wanted developers to be writing their automation tests as they were building the application. So it made sense to choose a JavaScript solution for that. At that time, there really wasn't anything out there that was suitable for PayPal. We did a survey and of everything that was available and didn't find anything. So we went ahead and developed Nemo, and over the course of a couple of years, we got it to this 1.0 version, the patterns, which we're going to look at today. And then we're going to obviously see how it works with Applitools Eyes, which is a product that we're also using at PayPal along with Nemo. At this point, our marketing team is doing a lot of visual test comparisons. So in terms of automation testing and Selenium, the question is, where does Nemo fit? So here's Selenium WebDriver, which is the client binding for Selenium, which I'm sure a lot of you are familiar with. You can get these in Python or Java or JavaScript. So the Selenium WebDriver starts the WebDriver server if necessary. It sets capabilities, and it has the WebDriver API for things like finding elements and executing scripts on the browser. And then it has the whatever control flows it might have. For example, in the Node.js world, it uses promises for its control flows. So the way Nemo interacts with Selenium WebDriver is Nemo is the green box here. It includes Selenium WebDriver as a dependency, and then you can add plugins to this setup. Nemo has a plugin capability, Nemo View being the most popular one, sort of the most powerful one right out of the box, and then other plugins as it may suit your needs. So we're going to see the Applitools plugin later on. So on top of Nemo, in order to have a full automation solution, you need something, some sort of test runner to do, unit testing and organizing your before and after and assertions and so forth. We use Mocha. You could use other, another test runner instead if you wanted to, like Jasmine or Cucumber also would work. And then a task runner like Grunt or Gulp. And the examples that we're going to look at will use Grunt. So this is what a basic Selenium WebDriver JavaScript looks like. If you go to the Selenium WebDriver repository, this is the example. And you can see it's quite verbose, and it takes a lot of work before you can actually get a URL. So, and also a lot of the information that's here is stuff that you would want to configure based on environments and other conditions, you know, in your test script. So there's a lot here that needs to be sort of packed away. And this is what the same script would look like if you're using Nemo. So basically, you just have to require Nemo, and because of how Nemo is handling the configuration sort of behind the scenes, you can easily get to the driver command, nemo.driver.get, and then the URL. So what does Nemo do to get us to that point? So it provides something that we call environment-aware JSON configuration, the plugin API, and then access to the WebDriver API. So between these three things, it really gives you a lot of power to determine how you're going to set up your automation. So the WebDriver API, which is documented by the Selenium project, is exposed as nemo.driver and nemo.wd for the other classes that you may need to use. And the environment-aware configuration basically starts with config.json. This is the default configuration file. And then if your node env variable is set to something like local, then Nemo will first load the configuration from config.json. And then after that, it will look for local.json. If it finds it, it will apply any overrides that it finds there. So in this way, you can have as many override files as you want, and all you have to do is set the node env variable to grab that particular one. Within the configuration file itself, you can have strings, of course, because it's JSON, but you can also use these things called short-stop handlers, which will reference other system objects. So, for example, when the configuration is resolved, if it sees env colon, it will look in the environment, the process.env, for a variable called foo. And if you have the path colon, then it's going to look for a file path on the file system, and so forth for these other ones. The config short-stop handler will look in another portion of your JSON config. So this also gives you another layer of power in your configuration. So your config.json could look something like this, where you're specifying a plugin, or two plugins actually. We've got the Nemo View plugin, and then we're creating this. So the Nemo View plugin is one of your dependencies in your node_modules directory, and then this util plugin is in your actual file system path just within your project. And then you basically need to specify a browser, which we're doing here, and that's pretty much the smallest config.json you might see. You don't need plugins, so you could really remove these other two pieces and then just have the driver in order to start up Chrome. So to give you a sense of what the sort of code patterns would look like if you're going to use Nemo, if you're using Nemo View and you're testing an application that is adding a credit card, or in a success and a failure scenario, then your code would look something like this. You're accessing nemo.view, and you've created some JSON files for login and card, and Nemo View gives you back these nice methods that you can call for your locators. So it gives a pretty nice code that you can read and understand what's going on. And if you wanted to make this a little more dry, as in don't repeat yourself, and make it sort of a shareable thing, then you can do something like this, where you package up all your card functionality into a module, like we've done here. And we've packaged up all of our navigation into a module here. And notice that these packaged up modules access various views. So we're accessing both the nav view, as well as the login view, as well as the card view. So we can mix multiple views into a single one of these. And then in your actual test case, you could use those modules, and you can basically write your code something like this. So it's very readable, it packs it away, and then these modules, this navigate module, this card and bank module, could all be used in other tests. So this is, you'll find this in our example app. This is basically what we consider to be the best practice pattern if you're going to be trying to share code while you're writing tests. specifically for what we're going to look at in terms of Applitools, I've additionally created this dynamic data file. It's just an array of 2 objects with a locality and a URL. So we're going to test an application that has multiple locales, and we're going to do some visual comparison with that. And here's what more or less what the spec looks like. It's going to loop through this countries array that we saw before, and it's going to do some WebDriver stuff to click a few buttons and then check for some text, and then we're going to be done. So let's take a look at what that's going to look like from WebStorm, and we're going to look at our sample application as well. So this is a sample web email application. It's responsive. If we size the window up and down, we'll see some elements flowing, and then we'll see some elements disappearing when we get down to about a phone aspect ratio. And right now you see we've got the DE URL. And inside of our application, we've got a properties file, which is going to represent what might happen if you're localizing an application. So you'll start out with, the mother language, whatever that might be, English in this case, and then when it's localized by your team that does that, you'll see some text change. So if I refresh this, now I see that we've got this translated string that broke the template, or at least the text is flowing under some other elements and it can't be read any longer. So the US version still looks fine. The German version now has this visual problem. So the issue here in terms of automation is that we're not going to be able to catch that. So here's our script again, and you can see what we're doing is we're verifying some text. And here in WebStorm, I've got this pre-Applitools Mocha configuration, so it's going to open up Chrome and open both URLs, US and DE, and it's going to click the buttons and try and verify that text. And you can see that everything went off without a hitch, and that's problematic, of course, because there is a bug there. So then the question becomes, how are we going to implement Applitools to catch this visual bug? So basically, what we can do is install another plugin and use it. Here's the configuration for that plugin, which we'll look at in a little more detail in a minute. And now we're going to run one test to Applitools and see how Applitools can try and catch this bug. So here's my Applitools account, and at this point I don't have any test results. So I'm going to run my first test into Applitools. First thing we need to do is see where our spec file is located. It's right here. We've got it open already. But let's see, I've got a little paste bin over here that I'm going to add some Applitools functionality. I'm going to interrupt the spec right there. So here's our config.json with just the Nemo view plugin. And now I'm going to grab the text of this Eyes plugin that we've written, and we'll configure it right here in the JSON. So you can see that we've got an SDK section which matches up with the SDK that's documented on the Applitools website, and we're going to pull the API key out of our environment so that it doesn't have to be in the clear here in the text file. And there's also this mock value or property that we can turn Applitools comparison on and off. So that's how we're going to configure the plugin. And here's the Nemo commands that we're going to add into the spec in order to actually run the plugin and do the visual comparison. So we're still verifying the text, but now after this text verification step, we're going to add Nemo.eyes, which is going to open up the Eyes API, and it's going to do a check window on this email view based on the locality. the current page. And if the test results are a failure, this is going to report a failure through Mocha. And I've added this unique key here, which will pass through to the spec in case we want to create new baselines as we're going. So before we run against Applitools, we're going to run in mock mode just to make sure that the script still opens up the page as we expect and does the other verifications. And it does. So now we can run it outside of mock mode and actually save some results to Applitools. So we still have no results there. Okay, so we're going to just, before we run this test, we're going to get a baseline, and the baseline is pre-localization. So let's change the name of this properties file so that the German URL isn't localized. So we're opening up the browser. And you'll see it resizing, and you'll also see it start to scroll as Applitools takes the full page screenshots. Okay, so these tests report as failures, and it's because this is the first time that they've run. So it's Applitools is capturing the baseline, and we'll see when we go into the interface that they actually haven't failed. They're just new tests. So now let's quote unquote localize our application and see what happens. Again, remembering before we had Applitools integrated that there was no test failure. It was passing without a problem. Okay, so we see one passed and one failed, and as we might expect, the failure came from the German version of the page where there is that visual defect now. Okay, so the next thing I'd like to do is I want to, since this is a responsive interface, I want to add the dimension of responsiveness to the testing. And if you've done any testing on responsive interfaces, you know that visual bugs can present themselves at different breakpoints, basically. So it's important to test at those different breakpoints, and I think visual testing is a big part of that. So we were going to add some additional JSON files, phone and tablet, which we'll look at in more detail in the demo. And we're going to test along two dimensions, per country and per form factor. So here we are back in Applitools. I've cleared out the tests again. And let's take a look at our config files, how they are at the moment. We've got the basic config.json, which we're now adding the set batch, which is going to separate this into a desktop batch, and the viewport is 1200 width. And in the phone.json, we're using phone as the batch, and we've got a width of 620. And tablet is a batch of tablet with a width of 950. So you see we've got three different breakpoints represented here, and as far as Applitools is concerned, we're going to segregate these based on their batch name. And instead of running them from the Mocha configurations up there, we're now going to use the Grunt task runner to run all three of these form factors in one go. So we have a task called responsive, and we're going to run 3 iterations with node n being set to desktop, phone, and tablet. And that value of the environment variable will enact one of the override files in the case of phone and tablet. So we're going to run this, and also note that we're running these in parallel, so we're now running 3 tests at a time. Okay, so since there were no test results previous to this, those are all reporting as failures, but when we look, we'll see that they're just new tests, and we've talked about that before. So we've got it separated in the interface here in a nice way, where we've got phone, desktop, and tablet reporting as different batches, and then within that, we've got our 2 locales. So you can imagine if you had more locales, you would get the reporting based on a number of those in that list instead of just 2. So now we're going to localize the application and try again. And I apologize, I didn't actually click in on, at least on the prior ones, I didn't click on the visual test results to see how Applitools is reporting the difference. But we'll look at the last failure in a bit of detail, and then Daniel's going to talk through in much more detail how Applitools does the visual comparison and how it reports failures. Okay, so now if we see that there's 1 failure per desktop, phone, and tablet, and I think we're obviously would be able to guess what those failures would be. It's going to be in the German version of each of these. So if I click in on the tablet, we see where the problem basically is, and we've got this pink highlighting around the translated string that basically broke our template. So that's my portion of the presentation. That was just a walkthrough of sort of how Nemo works and why we think it is such a great solution for PayPal, and why others should also consider it. It's open source, and also how it works with Applitools. And if visual testing is something that appeals to your organization, which almost certainly it does, then these two make a pretty good combination. So I'm going to pass it on to Daniel to continue the presentation.
Thank you, Matt. That was a great demo. Okay, so I'm going to talk about actually 2 things mainly, since we have attendees with different levels of experience. I'm going to touch the basics of visual testing in general, and then we're going to go to advanced and detailed features that Applitools Eyes offers. So, first of all, visual testing. So the basic idea of what visual testing is that you validate either your entire screenshot or part of it of your desktop or mobile or website application. And one of the key points that it's important for me to convey is that you're basically already doing it. Even if you're not doing automatic visual testing, or even if you're not using Applitools yet, you're doing visual testing. Whenever you manually open your application, whenever you manually test it, you're basically performing visual testing. You take a look at your application and you say, okay, that looks good, or you're saying something isn't right here. And the reason that you're doing it this way is because that just a single look at your application screen can actually give you a lot of insights about what's going on. One part of it is the actual visual validation. You take a look at a screen, for example, this screen, and you say, okay, I can see very clearly that something is wrong. There's a visual bug going on here. In this case, the graphs are overflowing the screen, the body of the web page. But also, when you take a look at the screen, you also have an additional validation that you perform in kind of a trivial way. You look at the content and you say, okay, the content is okay. That's what I wanted to appear, which means in turn that your database or your REST API server are also functioning correctly or not, depending on the results. So, okay, so you're already doing visual testing, but the important question is whether or not you're doing it effectively. So as you can see in the slide, let me ask you this. How many pages can you test? And can you do it each time you update your application version? And on how many browsers, operating systems, devices, screen sizes, localization, just like Matt demonstrated. And another key point is, even if you look at your application screen, are you sure that you didn't miss any bug or anything like that, especially after doing it several times over and over again. So what I'm basically going to try and answer is, how can it be done effectively? This is kind of a cool example. This is the Merck website on how it looks on IE 11. And it looks good. Everything seems normal. But when you go to IE 8, then you can see that the top bar, the header, is actually broken. It's separated from where it should be, and it doesn't look good. And the reason that these things happen is because it's very difficult to get a lot of coverage due to the different form factors, as we mentioned before. Okay, so as you can imagine, what I wanted to say was basically that effective visual testing, much like a lot of other testing problems, is solved using automation. Okay, so automated visual testing. This flow of testing is true for whichever visual testing application you're going to use, whether or not it's Applitools. This is the key step that you need to do when you do visual testing. I'll further detail about each one, and I'll explain where Applitools differentiate. So the first step is actually driving the application under test and taking the screenshots at the visual checkpoints, at the points that are interest to you. So for example, you can drive your application with Nemo, as Matt demonstrated, or actually you have plenty of options for that. You can either do WebDriver-based software, or you can use HP's LeanFT, for example, and there are several other tools, commercial and open source, that you can try and use. WebDriver CSS, for example. Applitools basically give you the option to use any tool you want for a lot of, for the most popular programming languages, using the low-level images SDK, which basically says, okay, you can just pass image to Applitools, and Applitools will do the visual validation for you, regardless of how you actually got the image. And these are examples to the different programming languages that Applitools provide SDKs for. But when you use Selenium, or actually WebDriver-based frameworks, again, such as Nemo, Applitools give you several additional, very powerful features that you can use. One of them, which was also demonstrated by Matt, is the full page screenshot. For example, if you use Chrome or Safari, then when you ask for a screenshot, you only get the visible part, the viewport part. Applitools provide a flag which automatically tells the Eyes SDK to scroll around the page and stitch the entire page together, so when you do the validation, you actually get the full page screenshot. This is actually available for mobile Chrome as well, for the Java SDK. Another thing is check region, which checks a specific part of your page based on either an element or a region or any other selector that you can find. Check frame, which stitches together an iframe. Applitools know to set the internal viewport size, which is crucial for stabilizing a baseline when you do visual testing, etc. So these are features that you get when you work with a WebDriver-based infrastructure. Okay, so this is an example code from a very simple test script with Nemo Eyes. The most important thing to remember here is that, and this is, by the way, this is true for all Applitools SDK. Applitools has three main stages when you run a test. You have the start test, you have the check window or multiple check window commands, and the close. So start test opens up a test in Applitools, check window verifies the screenshot, and close basically tells Applitools that the test is finished, and this is the point where you get the results, whether or not the validation succeeded or failed. Okay, so after you ran your test and you took screenshots, the next thing you should do when you're doing visual validation is basically compare the screenshot with some kind of a baseline. So this is kind of an amusing image, but it's very much true. One of the most difficult problems with doing automated visual testing is that a lot of visual testing engines give you false negatives. And let me demonstrate why. Let's take a look, for example, at the image on the bottom right of the screen. The part that's emphasized with the magenta rectangle, I'm going to switch over between two slides. And if you take a look at the zoomed in part, you would see that the pixels change. On the other hand, if you look at the image on the bottom right, then you probably don't see the difference. And this is due to anti-aliasing, which happens when you switch over, when you test, for example, the same web page on a different computer, a different OS, a different browser, different GPU. Each one of them can use a different anti-aliasing algorithm, and you get different pixels. And when bitmap comparison is done, then the result would be that you get a false negative. You wouldn't want this image to fail when you do visual validation tests, but it might. This is another example of such a change. This is a brightness change. And image scaling, of course, can cause problems. If you take a look at the top left part, which is a zoomed in part of the magenta rectangle, you would see that the pixels are completely different. And again, this would, in trivial engines, would cause false negatives. So Applitools is specifically adjusted to handle these kinds of situations, and the guideline is basically if a user does not see a difference, then the test should not fail. This is the guideline that all of Applitools algorithms work according to. In addition, Applitools also have a layout match level. Applitools actually provide different match levels. The default one is strict, which is the same as a human eye. And another is the layout, which basically compares the structure of your page. So if, for example, your page changed entirely, the entire content changed, but the layout is the same, then Applitools can say, okay, this is still correct. And I'll show you an example very soon. In addition, Applitools provide ignore regions or floating regions. So let me show you what this means. Okay, so let's go. By the way, this is the Applitools report screen. This is when you enter a test. This is what you see. We're currently on a step which is a failed step, which means there's a difference. You can see it because of the fact that it's red below. Now let's see what the differences are. I can click on this radar button here. So I'll do it again just to make sure. All those circles, the red circles, are places where differences exist. And basically, these are the regions which are highlighted with the magenta color. So let me put the baseline and the new image side by side. This is the baseline that we used. And this is the actual image that we've received when we took the screenshot. Now, I'll toggle between them. You can do this by clicking here or clicking T. Now, as you can see that I'll just hide the magenta highlightings and then toggle again. You can see that the Google logo on the top left part is moving, that the color here is changing, and there's a typo here. I don't know if you see that, but there is a typo. But what you also can see is that this part, the add part changes completely, as well as the user list and the contacts list on the left. But those aren't highlighted as different. And the reason that they're not highlighted is because the blue rectangle which wraps them is Applitools ignore region, which basically says this part can change completely and you can ignore it. It's okay. It's not anything that we want to compare. And you can do that by clicking this button right here and mark the region which is supposed to change. This is an ignore region. We actually also have a floating region, which is kind of different. You can create a floating region using this button. And what it does, it says, let's say that the Google logo can appear, both cases are correct. It can move somewhere in this area, but it should appear there. So the floating region enables you to do just that. You mark the content that you want to enable, that you want to say should be on the site but moving. As you can see, you have two rectangles. The internal one is the content which should appear, and the external one is where it can move. And as you can see, the Google logo is now no longer highlighted as a difference because it can move within the containing rectangle. By the way, another thing that I don't know if you noticed, Applitools automatically identified the outer rectangle. I didn't mark it. I just marked the Google logo. And Applitools found out that it moved inside this rectangle and automatically adjusted it for you. So we also mentioned match levels. Like I said, strict is the match level, the default match level, which is the human eye kind of match level. And you know what, I'll show even another interesting example. I don't know if you noticed, but there's actually another diff in the images, within the images, which Applitools ignores by itself. I'll use the exact mode, which is the pixel-to-pixel comparison. And now you can see there's additional diff near the A. Let me zoom in. Okay. And I'll toggle again. The triangle moves 2 pixels or 1 pixel to the left, which is, like I said, when you compare pixel to pixel, it's a false positive, false negative. But Applitools identifies that this is a difference which the human eye won't catch, at least trivially won't catch, and so it wouldn't bother the user, and therefore it says that this is actually not a diff. Okay. Cool. So let's go back to our presentation. So this is, by the way, okay, this is a cool example also. If you look at both images, you would see that the content is completely different. It's not at the same place. The articles are different. But Applitools only marks the upper part, which has moved to the left, overflowed actually to the left on the image on the right, and the missing image on the bottom part, the TechCrunch logo. This is because this is the layout mode for Applitools, which says, as I don't mind the content can change. I just want to make sure that the structure of the image of my website looks the same. And this is the case. We see that the structure broke on the CNN article on the right. By the way, this is a mobile test. This is a test from the Twitter application, as you can probably see. Okay, so we've driven the application under test. We took the screenshots. We compared them with the baseline. And now we want to take a look at the differences. So I actually showed you part of what it looks like when we're inside a test. Let me just show you what it looks like on the outside. So we use colors just like the trivial instinct that you have. Green means that a test has passed. Red means that a test has failed. Orange means that the test was aborted. This basically means that it was stopped, but not due to visual validation. For example, if you had a selenium error, some element that you could not find or anything like that, then this is the orange These are the orange tests. The grayed out ones are tests which the user saved, like the user selected either the baseline or the new image and saved a new baseline. So let's just go back to our Gmail application. As you can see, this test failed, and you can see the failed steps here, all those steps. Okay, so this was about reporting the results. So we had pass, failed, new tests, etc. I already showed you the toolbox and how you can use it to go over differences by clicking on the radar button to highlight the diffs and toggling between the images and switching match levels, etc. And okay, so you have a test, you see the differences. Now you want to decide whether or not you want to update the baseline. If the differences are because this is a newer version, then I would probably want to save this new image as a baseline. Otherwise, if this is a bug, if, for example, the Google logo shouldn't move, then I would want to keep the baseline. Okay. So we'll switch over from the presentation, and I'll just show you how to actually do it. So basically, the idea is that for each failed image, for each difference in the image, you would want to tell your visual validation engine whether or not this is a new image, a new feature that should be saved as a baseline, or if it's a bug and you should use the previous baseline. So in this example, let's assume that that the new image, you can see that this is the new image and not the baseline according to that to the label on the left. That the new image is okay. I want to save this new image, and the differences, by the way, let me just toggle again, are the Google logo which moved and the color which changed, as well as the typo. Now we'll just assume that the typo is okay and it shouldn't be more, it should be Mora. And I say, okay, this is the image that I want to use. So what I would do, I would accept the image by clicking here. Now something interesting is happening. Basically, if you see this message, two conflicts automatically resolved. What just happened is Applitools, in order to save you the effort from going over all the steps, identified that the changes in the step that we've accepted, the Google logo and the color and the letter change, also happened in all the other steps. And once it identified that, it automatically accepted for you the rest of the steps, because these are the same changes. Now, an interesting thing to notice is that, for example, this step, the step that I'm currently on, and this step, the step that we approved, the images are completely different. We have this entire part here, and if you'll take a look on the left side, then it also changes. But still, this did not stop Applitools from identifying that the changes, the diffs, are the same. And in which case, once you decided to accept them, it automatically accepted them for you. By the way, you can switch this behavior on and off using this button right here. We call this feature automatic maintenance. So once you disable that, then the auto resolve what just happened here wouldn't work. Another interesting capability of Applitools, which is kind of advanced, is, let's say I have a username in my test, and it's, for example, here it's Adam Carmi, and let's say that this might change every test. So I would probably want to put this in an ignore region, right? So I'll put an ignore region around this username. Cool. So now if the username changed, then this would not be a problem. But this username also appears in other steps as well. So instead of me having to go and put the ignore region in all other steps, Applitools automatically identifies that this part also exists in additional steps and automatically put the ignore region for me as well. As you can see, the rest, all these steps now contain the ignore region, even though I only marked it at one place. So this is also a very cool feature for Applitools. Okay, so by the way, after you finished accepting or rejecting every image, every diff, the one that you want at least, I mean, Applitools, like we said, automatically identifies some of the changes for you and performs the decision that you've already set in your original step. But once all the steps are resolved, and when I mean resolved, I mean that you've decided whether or not to accept or reject them, you click on save, and a new baseline, and the baseline would be saved. Okay, so let's move on. So these are the buttons which I've just shown you, and I think we're done. We're done. So just a minute. Adi, would you like to say something about that offer?
Yeah, sure. We have a special offer for webinar attendees. We have visually perfect baby onesies or T-shirts for adults. For anyone that runs a test with Applitools Eyes, once you run it, you can email me. My email is on the screen. We're going to leave it up there for the Q&A session, so you can have some time to copy it if you want, with coupon code Nemo1015. And we'll make sure you get it, and also you have the links to get Nemo and Nemo Eyes. And I will let Daniel take it up with the Q&A session.
Thanks, Eddie. Okay, so let's go over questions that were asked. As Eddie mentioned, we might not be able to go over all the questions, but even if we didn't answer your question right now, we'll send you a reply by email. So Matt, this is for you. Can you use Nemo with a cloud platform infrastructure like Sauce Labs? You want to take it up?
Sure. Yeah, you can. I wanted to put that in my slides, but we do have a Nemo Sauce Labs plugin to abstract some of the methods that you would call with Sauce Labs in terms of organizing your tests and so forth. So yeah, people at PayPal are using Nemo with Sauce Labs. I think we could do better about. We probably should put a screencast up on Vimeo to show how we're doing that, and I'll take that as an action item. But yes, the answer is yes.
Okay, cool. Another question for you is, what's your take on using Protractor? I mean, any pros or cons for using Nemo versus Protractor?
My understanding of Protractor, at least from the last time I looked at it, was it's fairly specific to testing Angular applications, and for that purpose, it's most likely pretty good. I don't have much experience with Angular or Protractor, but if you're testing Angular with Protractor and it's working out for you, then I think that's probably the best tool to be using. Nemo is not meant to be tied to any particular MVC framework.
Cool. Okay, so another question was, does it make sense to add eyes tests in your functional tests or separate tests for the visual checks? So basically, you can definitely add eyes to your functional tests. It's extremely easy, and eyes also have disable flags. So for example, if you want to run your functional test, which now has eyes along with them, you can just disable eyes, and it would run your functional test as if the eyes object isn't there at all, and without any code change. I would recommend, however, starting with just writing a few visual tests regardless of your functional test, just so you can get a feeling of what you can and cannot do with them, and how to actually do the visual test. Okay, so there's actually another question for you, Matt. What does PayPal use to test across various OS or browser combination? Is it browser stack or Sauce Labs? Just a second. Okay, so we'll answer that very shortly. In the meanwhile, there was another question regarding ignore regions. So basically, the question was, can you add ignore regions, use it through the actual test code, or do you need to do that through the web application? So currently, you do that through the web application. In a very short while, there will be an addition to do that through the code. You would just, for example, select an element using either a CSS selector or any other way that you use the WebDriver, and you can add the ignore region regardless of its location on the screen. And Matt, you want to take the question about the browser stack versus Sauce Labs? Which one is PayPal using?
Sure. Can you hear me now?
Yeah.
Okay. So people do use Sauce Labs at PayPal. I think generally, though, we use the internal grid infrastructure that's maintained by our platform team, which has a fair number of desktop browsers. But for anything that's mobile related, I think people would go to something like Sauce Labs, or if there's any other cloud mobile type providers.
Cool. So last question, and the rest of them will send reply during email. So the question is, can you elaborate on the frame, the get frame part? So yeah, the basic idea is that very similar to a full page screenshot. If you have like an iframe in your page, and it's only partly visible, right? Because it has its boundaries and size, etc. Then you can set the Applitools has a function to actually stitch the frame together with one command. That's the check frame command. And you can just call it, and you get a visual validation of the entire frame's content. By the way, you can do that to divs as well, divs with overflow, etc. Okay, so this is all the time we have. Adi?
Okay, so I hope you enjoyed our webinar, and I want to thank our hosts, Daniel and Matt. Thank you so much for hosting this great webinar. And I'm just reminding everyone that in a few hours I will be sending the online recording. So if you have a few more questions for our hosts, I'm going to leave the webinar open for the next few minutes. So feel free to ask if you have anything else, and we'll make sure to answer each one of you by email. So thank you again. Bye-bye.